Hi, Miriam.
Hi, how are you?
I'm doing fine. How about yourself?
I'm good, thank you. I have a question about the lab report that was due yesterday.
Okay.
So for questions, I think 8 and 9, when it says like there's a graduated cylinder that's filled to the top.
I told you, I gave you that answer last week.
Oh, really?
Yes, I did. I gave you the answer. It was whatever, how the precision that all the lines below that were, that's what the precision of the top line is. So for example, if you had a 50 milliliter cylinder, the smallest line was 1 milliliter, so that you could actually read it. You can estimate it to the 10th of a milliliter. Then you would have to record the 50 milliliter as 50.0.
Oh, okay. Thank you.
I did tell you, I swear to God, I told you that last week. Basically, I prefaced it by saying, hey, who wants some free points?
All right, thank you.
How we doing, guys? Thank you very much for indulging me. I got 7, I got 8 in here. Where are the rest of you? Aya's here. She said so in the chat room. Okay, so Gaith. Gaith here? Davila, I see you. Come on, don't be shy, Davila.
Hi.
Am I saying it correct?
Yeah, Davila.
Okay, good enough. Okay, Monica. Monica? Terry, you hear Terry? Terry? Sophia? Apple Grace? Hunter, you hear Hunter? I see you.
I am.
Okay. And Landry, I saw. Maverick, you here? Maverick. Tyler. Apple Grace is in. Tyler. Aya's here. Jeff.
Here, sir.
Thank you, sir. Grace Martin. See you, Grace. Katie. Katie here yet? Mateo.
Yes, Professor, I'm here.
And Maverick's here too. Mateo's here. Faith.
I'm here.
Thank you. Jennifer, I saw. Victoria. Victoria said she was going out to eat. Michael.
I am here.
Thank you, sir. Philip.
Yeah, I'm here.
Thank you, sir. And Miriam is obviously here. So going back, Apple Grace is here. Sophia, Terry, and Monica. Okay. Ladies and gentlemen, we're doing density tonight, right? Michael, is that correct? Jeff, shake your head. Yes.
Yes, sir.
All right, we're doing density tonight. This is important to you for a couple reasons. Not only are you going to be tested on it now, but during the final practical. That's what your practical exercise is going to be. Although at this point, I don't know exactly the formulation of it, but I do know you're going to have to give a density of a solid, density of a liquid, and that's going to be 2 of the 4 exercises you're going to have to do. Okay? So bears in mind to pay attention to what we're dealing with tonight. So can you see the slideshow?
Yes, sir.
Yep.
Yeah.
All right. Now, the way they treat density, the way they treat density is they use something called the density triangle. And it makes a whole lot of sense if you think about it. It's an easy way to get a fairly easy problem. Because generally speaking, you're going to have, you have three things. You have density, mass, and volume. Generally speaking, you are either going to be given two of the three and asked to solve for the third, or you're going to be given a way to get two of the three and solve for the third. Does that make sense to you?
Yes, sir.
So basically, this thing here with the triangle aspect, there is a line. There's a line between mass and it's over density and volume. So if you have the mass and you have the volume, there's a line between mass and the volume. So divide the mass by the volume, you're going to get the density. If you have the mass and the density and you want the volume, all you got to do is divide the mass by the density, you get the volume. Third way, density and volume are kind of like on the same level, and they're kind of right beside themselves. So if you have the density and the volume and you want the mass, all you got to do is multiply the density by the volume. Now, that's one way to do this. The other way that you can do densities or understand densities is by looking at the labels.
And we'll take the sig fig number from whatever's smaller from the two, right?
Yes, because it's all multiplication division. Smallest number is sig figs. This is sig figs of your answer. So if you have grams and you have volume and you want the density, what are the labels of density? What per what?
Grams per milliliter.
Grams per milliliter or mass per volume. So if that's what we're trying to find out is mass per volume, and we have the mass, all we have to do is divide it by the volume, and our labels are mass over volume. So all we're doing to get the density using the label theory here is we're dividing mass by volume. Okay? Say we have the volume and the density. And we want the mass. Well, the volume is going to be in a volume label. If I just multiply that by density, which is mass per volume, whatever label the volume is going to cancel, is going to go away, and we're going to be left with the mass. Again, we have the grams and the volume. We want the density. We're just going to divide the two of them. If
We
we
could
have
just
the
use the
volume,
formula, right?
what's that?
We could just use the formula,
Yeah,
work out, okay.
that's Monica. That's all you're doing. All I'm trying to do is I'm trying to give you two different ways to look at doing density. Densities are probably one of the easiest problems you're going to get. On the other hand, if I have mass and density, this one you got to work out a little bit. And I want volume.
Divide it, right?
Divide it or multiply by the reciprocal, which is how you divide fractions. If I have mass and I have density, which is mass per volume, if I just multiply it, I get mass squared over volume. Whereas if I take this and divide it by the mass divided by the volume, this is the same thing as taking the mass and multiplying it by the volume over the mass, which will get me the volume. I know I'm belaboring the point. I'm just trying to show you there are different ways to go about solving these problems. Generally speaking, you're going to have two of the things, use those two things to solve for the third. Okay? Now, let's talk about things. Jeff,
Yes, sir.
do you think you can weigh things?
Probably, yeah.
Do you happen to have a bathroom scale in your house?
No, I do
No?
not, unfortunately. No.
Okay, I'm sorry. Philip, do you have a bathroom scale somewhere in your house?
I don't know.
Monica?
I also have a food scale.
Okay, food scale, that will work. That
Okay,
works.
which
So what I want you to do, Monica, is I want you to go to the tap, go to your kitchen tap, put your hands, and she's actually doing this. I don't believe she's
oh
actually
you
doing
oh
it.
you didn't want me
Yeah,
to
just
do it?
listen first, okay?
Okay.
All right. Monica, I want you to take your hands, put them underneath the tap. Then I want you to carry the water over to your scale and weigh it.
In my hands? No, you want me in a
I want you
I
to
didn't
weigh
hear
the
the
wa-
first part.
I want the weight of the water. And wait,
Okay.
she's not actually doing it, is she?
Oh, no, she
Monica,
is.
Monica,
Yeah,
can you
I'm
do
doing it.
it? You put the water on the balance. Where's the water gonna go?
Oh, if you don't have it in a container, it's gonna go everywhere.
Exactly. Can you, Monica, can you
I
measure?
was trying to get your point. I didn't know what you wanted me to do. Okay.
Monica, can you measure the weight of water directly? The weight of any liquid?
I guess no.
No. You can't measure the mass directly. Can you do the volume directly, Monica?
The volume.
Yeah, if you had a measuring cup, can you measure
yeah.
out 8 ounces for me?
Yeah.
Right? All you gotta do is pour it in. The lines are marked there, right? You have 8 ounces. But you can't measure mass directly. So what you have to do when you're dealing with a liquid, you have to weigh a container. Then you pour the liquid into the container and weigh the container and the liquid, and you have to subtract the weight of the filled
Container. Mm-hmm.
from the weight of the empty container. That will give you the weight of the liquid.
Mm-hmm.
Now, do you want to go
And
weigh
then
some
that's
water,
how you get your
Monica?
density. No, I got it. You're just trying to say that, yeah. So you take your mass or your grams, and then you divide it by your volume, which is going to give you your density.
So that's how, anytime you have a liquid, you have to do this. And what makes it convenient? Usually you can use something like a graduated cylinder. So you put the empty graduated cylinder on the balance, fill it up with a certain amount of liquid, read the volume. You have the mass beforehand, you have the mass afterwards, you got the density. Simple, sweet, right?
Yes.
So if you have a mass of a cylinder without the liquid was 32.643. The mass of the flask and the liquid was 42.893. You looked up, you saw the volume was 10.2 milliliters. So for me to get the density of that liquid, I have to subtract the 32.643 from the 42.893. That gives me the weight of my liquid. At that point, I have the weight of my liquid. All I got to do is divide it by the volume I saw. I have the density. Sweet, right?
Yes.
Okay. Now, that's liquids. Let's see. Tyler, you out there? Tyler? Okay, Tyler's not here. Grace, are you out there, Grace?
Yeah, I'm here.
Okay, Grace. So we just decided that for a density, we can't measure the mass directly. We got to use a container, right?
Yeah.
What about a solid? Is there something you can measure directly with the solid?
Like, can you measure a solid directly?
Yeah, can you do something like put it on something and get one of the measurements we need? Either the
Yeah.
volume or what can you do?
You can weigh it.
You can weigh it, right? You have
Yeah.
a balance, you have a nice solid object, throw the solid on the balance, you can get the weight directly, right?
Yeah.
What about the volume?
I think you're gonna have to put it in something.
You think so?
Yeah.
You're absolutely certain. You'd be willing to bet this, you'd be willing to bet your results section on that last statement.
I don't know about that.
Okay. Like the old man who's telling everybody what kind of underwear he has. It depends.
Good one, Professor.
At least Jeff got it. Okay. It depends when you're dealing with the solid. I really made you lose it, didn't I, Jeff?
I was just not prepared for that.
I was mildly concerned why we were talking about old men talking about their own undergarments, but
You
good
should
pun.
see him in lecture.
Oh,
Okay. You're never going to forget
I've heard
this.
rumors. That's all.
I'm not going to go there. I don't want to hear it. All right, Sophia, can you think of an example? Can you think of an example where you could measure the volume of a solid directly?
Like without dipping it in water and like,
Yeah, without dipping it in water.
maybe this is a bit of a stretch, but I know that gallium is a solid technically, but it melts at room temperature, meaning it would be a liquid then, and you're measuring that both by grams like you would with the solid, but also milliliters, which you could do with liquids. I don't think that's what you're asking, but that's the first thing that came to mind.
There's actually a trick that you can do with gallium. You can mold it into a spoon and you can give it to somebody and ask them to put sugar in their coffee and it melts.
I did that with a ring for my grandma. It melted all over her shirt.
But no, that's not what I'm talking about, Sophia.
My
I'm
bad.
trying to think if I have an example somewhere around here.
Are you referring to a wooden block, like a
Ooh.
cube?
Can we get the volume of a cube?
Yes.
How can you do that? What magical instrument are you going to use? What magical instrument are you going to use to get the volume of that block?
A ruler.
Width, length, and height.
So if a solid is regularly shaped, you can get the volume by measuring and then applying some sort of formula. Does everybody buy that?
Yes, sir.
If I have a block, I can measure length, width, and height. I have the volume. If I have a sphere, generally speaking, it's kind of hard to measure the radius. So what you do is you measure the diameter, divide that by 2, and then apply it to 4/3 pi r cubed.
Say that again.
4/3 pi r cubed.
No, the whole formula for, you said a sphere.
A sphere. What you generally, it's Hunter, it's hard to measure the radius.
Yeah,
It's much easier to measure the diameter.
yeah.
So what you do is you measure the diameter, divide it by 2, you have the radius, then you use that number and the formula 4/3 pi r cubed.
Okay, 4/3 pi r cubed.
That is the formula for the volume of a sphere.
Okay.
All right. So it all depends upon whether you have if you have a regularly shaped solid, you can do it. You just do your measurements, figure out which formula you got to use, and then you measure the mass directly. What happens if you don't have a regularly shaped object?
There is a formula for that.
And-
Can you,
And what
It's you need the volume of it?
yeah, I want the volume.
Oh, I have the density of it, but
How do you get the volume of my cell phone?
You have
do
to-
you get to use the water displacement thing?
Not with my cell phone, you don't.
volume
Yes.
is
Yes, that's exactly what you do. It all comes down to Archimedes' principle. And Archimedes' principle said, when you place an object into water or into a liquid, the volume of that liquid will be displaced to the same amount as the volume of the substance that went into it. So in other words,
Even if, okay, I have a question though. Even if it's miscible,
yeah,
oh,
because Hunter, even if it's miscible, what happens is you're still adding liquid. Doesn't the volume go up? You put alcohol into water, Hunter. You put 10 milliliters of alcohol into 20 milliliters of water.
yep. Will the volume change?
The volume, yes, the volume
Yeah.
will go up to 30.
That's what I thought.
It's off a slight bit because there is constriction when you're actually dealing with dissolution. But for the most part, that'll work for the most part. When you put one object into another, it will displace the volume of the original liquid to the same quantity that it has a volume.
Wait, so like there has to be another way though, because if you think about it, like you can't put everything in water without like ruining it. So like how do they get the volume of an irregular shaped object that they can't put in the water? Like they'll I guess they can get the mass and then
Hunter,
don't know.
what you would use, if you have some problem like dissolution in water, you would just use a solvent that the substance doesn't dissolve in.
gotcha.
Like if you had a big sugar cube. Okay? Sugar doesn't dissolve in gasoline, does it?
I've never tested that.
Try it. Try it and then go put it in your gas tank and
Oh.
tell me what happens. Don't do it.
No, yeah, I'm not gonna do it.
So when we have an irregularly shaped object, the mass is directly determined, as we previously stated. Then what we're going to do for an irregularly shaped object is we're going to put some liquid into the vessel and we're going to note the volume. All right. When you're doing this, you got to make sure that the level of the liquid is above the level of your solid, because if you have a little bit of solid sticking out, then it won't work because not all of the solid is in the liquid. So the volume of the liquid has to be a little bit greater than the height of the solid you're putting in there. You note the volume before you add the solid, then you gently add the solid. If I was doing it, I have a graduated cylinder, I would tilt the graduated cylinder, then put my solid in and gradually increase the height until it slides down the edge. The reason you want to do it that way is if you just gadunk it, liquid's gonna splash up and you're losing liquid from what's down there. That's one thing. And the other thing is, if you could dunk it into glass, a glass cylinder, it's going to break. So after you slide it in, you're going to have the final volume. To get the volume of the solid, you take the final volume minus what the liquid was without the solid in it. That will give you the volume of your solid. So I have an irregular solid. I fill up a graduated cylinder to 17.8 milliliters. I then slide my solid, well, I weigh my solid. It turns out to be 6.543 grams. Then I slide it into the cylinder with my water. The final volume of the water was 25.3 milliliters. To find the volume of the solid, I just subtract final volume and initial volume. That gets me 7.5 milliliters. I've weighed the mass at 6.543. I then divide the mass by the volume. I have my density.
I have a question.
I'm here.
So I understand, like, you know, the formula, the concept, but when I went to do the actual lab for this one, the lab 4, I really had a hard time like following what like the student results, the tier 1, tier 2. Like I had a really hard time.
Tier 1, tier 2.
Yeah, like it was just, I mean, I was just wondering if you're
the
gonna go
picture's
over.
like, I don't know. It was kind of confusing. I agree.
Okay, well, we're gonna look through it. That's
Okay.
what I'm gonna do after I'm done with this little bit of nonsense
Okay,
I have
cool.
to do yet, okay?
Okay, cool.
All right, if I had a regularly shaped object, I had a bar that had 7.8 centimeters, a width of 4.75, and a height of 1.45. If its mass was 354, I gotta find the volume first. I have a bar, measure length or multiply length, width, and height. That gets me 53.7 centimeters cubed. I know it weighs 354. Divide the weight by the volume. I have a density of 6.59. All right, now, hold off on this. Let's hold off on the graphing. I'm going to go make sure that we have to do graphing here. If you don't have to do graphing, then we're not gonna.
I think graphing is our next lab after.
I understand that, but
Okay.
if I don't have to discuss this now, I won't. I had to discuss it for my HCC class, and this PowerPoint's part of it. That's why it was there.
Got it.
Okay, so that's basically the theory behind what we're doing, why we're doing the measurements that we're doing. Okay, I'm in the course content. Now, Monica, describe where you want me to go to find this crazy looking tier thing.
So go to this is 4, right? Module 4. I mean, yeah.
Experiment
Module.
4. Yeah, I'll get there in a second.
Okay.
I'm here.
And then I guess you're supposed to use because I tried watching the video and I was like, but then I tried watching looking at the student results. So the student results is, I was trying to follow that to enter data into, the actual,
Okay, wait a second. I'm
Is
trying
it
to find it.
this?
the student results.
I don't know if
I
you can
can't-
see that, but it has like a, can you see it now?
Mine looks different. Hold on, I'll show you.
Is it
Talking
like,
about the mass and volume one, right?
yeah, or, oh, wait,
Oh, I'm in the wrong lab.
I'm also in the wrong lab.
Yeah, it'll say
Cool.
student results on it.
There we go. I was wondering what in the world was going on here.
Same.
Okay. Monica,
Yeah, if you could
are you
open that for me.
seeing this slide now?
Yeah,
You want me in student results, right?
yes, correct.
Okay.
So,
So
okay,
Part
yeah, so
A.
you can. Mm-hmm.
part A, I believe you're supposed to determine the density of a liquid.
Okay.
All right. All right. The first thing is an empty graduated cylinder. Okay.
Mm-hmm.
All right. So the second thing is the graduated cylinder plus the liquid.
Okay. And
Empty
then the third.
top one,
Mm-hmm. So cylinder by itself, and then
cylinder by
cylinder plus
itself,
liquid.
cylinder plus 4 point
Mhm,
whatever, 4.4 milliliters. Okay.
mhm.
Then if you read the experiment, which Monica, I'm guessing you didn't read the experiment.
I swear I was trying to put it together, and I know I
Monica.
wasn't that tired.
Monica, read the experiment. Don't direct,
Okay, I will.
because what the experiment tells you to do is you're supposed to put between 4 and 5 milliliters into a graduated cylinder and weigh it.
Yep, I got that. And
Then it tells you to add more liquid to the graduated cylinder and weigh it again.
oh, okay, I think that's where it was throwing me off, because I was like, what? It's already doing this. Okay, cool.
So basically what you're saying, the top weight is the weight of the empty graduated cylinder.
Mhm.
The second weight is the first 5 milliliters of liquid or so. It says between 4 and 5. Okay. So in this case, this is the weight of the cylinder plus 4.4 milliliters of liquid. Got that,
Okay.
Monica?
I got it.
Then you added more liquid to the point where you're at 9.8.
Got it.
Okay. And this is the weight of 9.8 milliliters of liquid plus the graduated cylinder. Does that make sense to you now, Monica?
Yes.
All right. So I'm going to move everybody over here. So that was part A. Part B. Okay. Part B was the weighing of the rubber stoppers, correct?
Yes, it is. I'm still looking at the part A. I apologize.
Okay.
But yeah, part B is the rubber stopper.
So you put the rubber stopper on the triple beam. That's the weight you get for the rubber stopper, okay? For the rubber stopper, you had to fill the graduated cylinder to a certain level. Then you put the rubber stopper in. The right side is the
Final
volume rubber stopper plus the liquid. Monica, is this helping everybody out?
Yes.
Yes.
That's what I did. I went through the
Yes.
student results and I just kind of wrote it down, like the measurements. But you're saying that the difference between part A and part B is like the rubber stopper? Or?
No, Hunter, if you read the lab, part A tells you to get 2 different densities of the liquid. The first one, you're putting about 4 to 5 milliliters in. You're weighing the graduated cylinder first, putting between 4 and 5 milliliters of the liquid in, then weighing the graduated cylinder and the liquid.
Yeah, because it was 30 grams for the empty graduated cylinder. And then there was 4.5.
4.4.
4.4.
Yes.
Or yeah, okay. I guess I eyeballed it wrong, but 4.4 milliliters in there, right?
Yes.
All right, and then the difference, because the empties is 30 grams, right?
It was 30 even.
Okay, and then what I saw on the scale was 33.90 G.
Okay.
So, and then I recorded trial 2 as 38.8
Okay.
or 80 G.
So you tell me, Hunter, how many grams does the 9.8 milliliters of liquid weigh?
30, what with the flask, then it would be 39.8.
I want to know what without the flask.
than just 9.8.
So you got 9.8. How much is the volume?
The volume for trial 1 was 4.4,
But trial 2,
10.1,
no,
or 10, just 10 then,
10 even.
10 even.
Okay.
Okay, bottom line. This is the weight of the empty cylinder. Okay?
30.
You added an amount of liquid to the graduated cylinder. Then you put the cylinder with the liquid back on the triple beam. This is what it weighs.
Hmm.
Determine a density.
So everything stayed the same there except for that small scale.
No, it didn't. Hunter, you went from 30.00
Yeah.
to 33.9.
Yeah.
What's
so
the weight of the liquid?
3.9.
Thank you.
Yeah.
So you have the weight of the liquid. Do you have the volume of that liquid?
Yeah.
Determine
And that's
the
what it
density.
was.
Oh yeah,
I
we have
had,
the
I
we
had
have
not
the
spotted
volume.
that.
1 second,
Okay,
Hunter.
so we have the mass and we have the volume now. So now we'll be able to get
The
Density.
density.
the density.
Okay, now
Where the
what
hell-
you did next, Hunter, is you added more liquid. You added more
Yeah.
liquid to the cylinder, and you put the cylinder and the more liquid on the balance again. And
Yep.
it weighed 38 point something,
38.80. That's what I
38 point something, okay? Now, you have the, can you get the weight of just the liquid?
yes.
How are you gonna do that?
We'll take that 3.9 and then we're gonna, or that 33.90, and we're gonna subtract 38.80.
No. That would give you, Hunter, that would give you the weight of the second aliquot of liquid. I want the weight of the whole liquid.
Well, then we could take the trial 1 volume, like in the test tube, which was, you said 4.4, or we can do 10.0 minus the 4.4. Now we have 5
Hunter,
points.
Hunter, how are you going to get the weight of the 10.0 milliliters of liquid?
Well, we're gonna need the volume or the density, right?
No,
Well, you tell me. I'm drawing a blank on this one.
Hunter, do you know the weight of the empty cylinder?
Yeah, it's 30 grams.
So, do you know the weight of the cylinder and 10.0 milliliters of liquid?
Yeah, I thought it's 38.80.
So you tell me, how are you going to get the weight?
So
of
it's
the-
8.80.
There we go. There we go.
All right.
Everybody clear about part A?
Oh, we're just doing the same thing from trial 1 and just doing it in trial 2.
Yes,
That has nothing to do with trial 1 because it's already done.
it's, well, what should the densities be? What's the relationship between the density of trial 1 and the density of trial 2?
Well, we poured that extra liquid in there, so the difference is we poured 8.80 into there.
Is it the same liquid we're pouring in, Hunter?
Yeah, I think so.
If it's the same liquid, then what is the relationship of the density of trial 1 and the density of trial 2?
We increased the density.
Did the mass stay the same?
No, the mass increased,
Or the mass, yeah, the mass did increase because we put that extra liquid in there.
but did the volume increase?
Yes.
It's the same liquid. It's the same liquid. So what should happen to the densities from trial 1 to trial 2? Somebody help us here.
It would say the same. I mean,
Yeah, it's the same liquid. You're just doing a second trial of the same liquid to get the same density. So you
So the
can
only thing
compare
that's
the two.
changing here, the only thing that's changing here is mass and volume, right?
Yes.
Yeah, but if they change equally, then it should give you the same number.
It'll same density number, right?
Yes, because like think about it, because like say you have 20 over 2, that reduces down to 10. If you have 40 over 20
Four.
over 2 is 10. 40
Yeah.
over 4, 10. Yeah, so it's
Okay. I see that. I see that now. Sorry. I
No,
don't know.
no,
I'm getting, like all mixed up with all this stuff, especially when I threw in the sig figs. I was like, I don't know.
oh yeah.
okay,
You know what
time out. Let's start doing something from now on. Don't pay attention to the results section. I will go over them with you next Tuesday.
The student results?
Yes, don't go over them. Don't touch them.
Oh, because I thought, isn't this due, or when is this due? The 8th?
It's due next Tuesday or next Monday.
Next Monday. Okay, yeah, because I
You got a whole week. After I give this talk, you have a whole week. What I want you to do is I want you to read the experiments, because you're not understanding what this can't mean anything unless you know where these were created. Does that make sense to you guys?
Of course.
Yes, sir.
So you got to read the procedures as to what you're doing in order for this to make sense. Does that make sense to you?
I honestly had just not spotted those test tubes. So I
Yeah.
was like, what in the world? But yeah, and once you pointed them out, I get it now.
Okay. All right, so that was A. We're going on to the second part. The second part was doing the density of a rubber stopper. So what you're doing here, what the instructions tell you to do, is to place the rubber stopper on the balance. Get the weight of it, which is what you're reading with the triple beam here. Then it tells you to fill the rubber stopper to a level, I think it does say about 12 grams or 12 milliliters. Then you're supposed to put the rubber stopper in there. So the left graduated cylinder with the volume marked is the before you've added the rubber stopper. The right one is after you've added the rubber stopper.
Yeah, and the first one, that's 10.2, right?
No, it's 12.
I can't see it.
You're going from 10 to 20. Each line is worth 1 milliliter.
10.12? 10.
No,
No, like literally, like the number, like
12.
12.
Oh, yeah. Oh, yeah, that makes sense. What am I talking about?
okay. Are we okay now, guys?
Yes, sir.
Part C. Part C is a lot like Part B. The only difference between C and B is instead of using a rubber stopper, you're actually using pellets of metal. Okay? So the first thing you're doing, you're putting the pellets of metal on the triple beam. You're getting the mass of the pellets. This case, you filled the graduated cylinder to that level there. You added the pellets to it, and the amount of volume rose to this level. Subtract the amounts of the volume, divide that into the mass, you have the density of your solid. Also, you have to note
That's going to be
that-
like 2.5, right?
Hunter, doesn't make sense if you keep on saying this and I keep on saying yes. It doesn't, I might as well be writing the report for you.
Oh, my bad. I'm
Okay.
sorry.
The other thing you need to note, you are going to get the density by doing this exercise, the same as you did the rubber stopper. Once you get that density, you're going to compare it to the list of metals which is in the laboratory manual to identify which metal it is. If the densities match, then the identification. Density is a good way to identify elements and compounds. Questions on that?
No, sir.
Now, the last thing. All right. First thing he gives you is the empty graduated cylinder. You have 3 liquids. And eventually what happens is you are going to add these 3 liquids to another test tube, densest first, next dense second, least dense is the third one you're going to add. Okay? Now you got to figure out what the density of each one of the liquids is to do that. So he gives you the empty cylinder weight. Then he's got a volume of liquid A. He tells you how much that weighs. So you can get the density that way. Remember, you still have the weight of the empty cylinder. You next put the second liquid in there. Get its weight and volume. So you can figure out its density. Then you are going to do the third one. You're going to get its weight and its density to figure out its densities. Now you have all 3 densities. You now know which one to pour in first, which one to pour in second, which one to pour in third. Monica, are you talking to somebody?
My little one's around, sorry.
Okay, no, that's fine. I just thought you were praying to God.
Nope.
Nothing to do.
Unless it's Captain America. Watch this real quick. Let's see the video.
Oh, beware of that shield.
That is very precious. Oh my
What's his name, Monica?
Matthew.
Hi, Matthew.
Say hi. Hi,
Hi,
Captain
Matthew.
America. Okay, sorry.
No,
Interruption over.
that's okay. At least, hey, warn him not to fly. My granddaughter, I'm not kidding you. My granddaughter fell out of a 3rd-story window.
Oh no, I'm sorry.
Yeah.
Was she okay?
Oh yeah, she was fine. She broke her collarbone, but we call her our flying child.
You should call her a cat.
Yeah.
Maybe she has 9 lives.
Okay, so we're good with this. We're good on how to do all the densities of the various things, right, guys? We're good
Yes,
with
sir.
that? All right, now I got to go into the miscibility study. Because I got to show you the pictures that are going on with that. Metal density key. So I'm trying to find out where that thing is. Nope, it's not that. Oh, I know, I'm sorry. I know where it was now. Got to be in the video. Are you seeing the video?
Yes.
Okay. I got to move this thing over now. He actually goes through all this stuff, but what I want to show you is the very end part. We're going to sit and watch this part. Hey, give me a break. I cut you down to 1 minute from 9. All right. When you add, remember I told you were going to add the 3 liquids to a larger test tube? Densest first, next dense, least dense. You get 3 layers like this. Okay? Now, does this layer mix with this layer?
No.
No,
How do you know that?
because it's separated.
Okay. Now, does this layer mix with this one?
No.
All right. Now, the $50 million question. Does the bottom one mix with the top?
No.
No.
Are you willing to bet your results section on this?
Wait.
Yes.
We
Yeah,
don't know.
What?
It's-
What was that?
We don't know.
Has this one, as the top layer, ever been in contact with
No,
the bottom
it
layer?
hasn't. So if the middle layer were removed, then we would know if it does or it does not.
There you go. Or you have other ways of knowing this.
Lost in the sauce here.
What you can do is you can add something in there, and that's what he's going to do here.
Can't hear it.
I think it's because you have your earphones in.
What's that?
I think it's because you have your headphones in.
I don't have any headphones.
No, Mr. Popovich.
You can
Because, you
also
know,
see this video, you know, like
No,
Yeah,
it's-
I've watched this video already. I've written
One
it.
second, 1 second. Trust me on this. Sorry.
Of iodine water.
Now you should be able to hear it.
Yeah.
Okay, he's adding
So just adding it in
iodine.
through the top of
He's
the
adding
test tube here.
iodine water to it.
Okay. Now what I'm going to ask him to do is to go ahead and swirl a little bit. So now what's happened is we've added the iodine water. Cannon has been swirling it quite diligently, and what you can see here is the final effect. We've got, you can barely see it, but there's purple, that's yellow, and that's purple on the bottom as well. But you just hold it up just a little bit. There we go, and you can see the purple on the bottom there.
Trust me on,
Right, thank you.
trust me on this. If you do this correctly, he didn't shake it up enough. If you do it correctly, this layer ends up being purple and the top layer ends up being purple. The layer in the middle is brown. So
Yellow.
does that give you any indication as to whether the bottom and the top layer should be miscible?
For sure.
Why?
Because it penetrated both the top and the bottom. That sounds really bad, but yeah, it did that.
I think I know what you're trying to say, Andrew. I'm sorry, Hunter.
Both layers are the same color, so that's why they would be miscible if the middle layer was taken away.
Both of them dissolved iodine in the same fashion, correct? You know they did because they're the same colors. So if they dissolved iodine, then they should be able to dissolve each other. Does that make sense to you?
Mm-hmm.
So what are they? It's like
Uh,
little.
What happens is, I believe, I'm sorry, I'm trying to remember. One of them is chloroform. I think one of them is hexanes and the middle one is water. Okay. Now, I do this experiment a little bit differently. I have the 3 layers. Then at the very end, what I do is I put my finger on top and shake the whole thing like this. And the 3 layers go to 2. I just shake it up and prove to you that the top and the bottom layers do dissolve. All right, do we have any questions about where the data is coming from, what the data means? We fairly good on that now? Monica,
Yes,
Monica, you're shaking your head.
I don't like this lab. It's probably super simple, and I'm probably overthinking it.
I mean, I tried to get started on this lab, but now that, like, I don't know, it's becoming a little bit more clear now. And this one, you just gotta, because I did the rubber stopper, like I wrote down all the instructions, but like for some reason I wasn't correlating it to like the different parts. Like I just thought the student results was talking about a different thing, but it's talking about the instructions, like, you know what I mean?
Yeah, I understand. That's why I'm trying to emphasize for you
have to read it.
You have to read the lab to make
it.
it.
But for some reason there was a disconnect or something. But it makes more sense now that we put it this way. I just got to nail the measurements, and I should be good to go. Or we should.
Okay, let me see. Where is that? Did I cancel out of it? Let me get back. I want to get back into. Oh no, that's where it's at. Okay, yes. Okay, now let's go to the results section. The report. I like to go through this with you guys. Are you seeing the screen?
No.
No.
Are you seeing it now?
Yes.
Yeah.
Okay. Start quiz. Okay, again, first question, don't bother with it. Second question, calculate the mass. Remember that this was the one with the 2 different additions to the graduated cylinder with the 2 different masses. Do you remember that? Okay. Calculate the mass. You have the mass of the cylinder. You have the mass of the cylinder in the liquid. Calculate the mass of the liquid. You have the volume. You now have the mass of the liquid. You have the volume. Calculate the density. Are we okay with that? Monica, even? Does that make sense to you, Monica? Okay, good. Okay. Second trial. This is after you've added the second amount of liquid to the graduated cylinder. You have the new volume. You have the total weight of both additions of the liquid to the graduated cylinder and the graduated cylinder weight. You have the weight of the empty graduated cylinder. Calculate the mass of the total liquid. Then calculate the density of the total liquid. I'm seeing the same 4 faces. People that I'm not seeing. Is there any confusion? I'm seeing Monica, Jeff, Hunter, and Victoria. Is there any confusion amongst anybody else out there?
No.
No.
We're pretty solid on this?
Yeah, I'm
Yes.
solid.
Yeah.
Okay. All right, now the second question was part B of the data. You need to calculate the volume of the rubber stopper. Remember, we had the volume before the rubber stopper was added. Then we had the volume after the rubber stopper was added. Calculate that volume. The weight was given. It was just, you just read that off of the triple beam of part B. So you have the weight, you now have the volume, calculate the density of the rubber stopper. Density of the unknown metal. For this, guys, put any number in there. I don't care what you put in there. It doesn't matter, all right? Put any number in there. Now, question 7 is going to be part C, and you're going to do it the same way you calculated the density of the rubber stopper. You've got the volume of the metal sample. You have the volume before it was added to the cylinder. You have the volume after. Determine what the volume of the metal sample was. You have the weight of the metal. You also now have the volume. Determine the density. Miscibility of liquids. You've got the 3 liquid samples. You have to show me, this is a big point total, guys, 30 points. You have to show me how you got the densities of each one of these. Remember, it's the same way as you did the first density in this study. So you've got the 3 densities there. The next step, okay, you're going to have to manipulate this. You're going to have to say, okay, liquid C, is liquid C layer 1, 2, or 3? Is it the densest? If you think liquid C is the densest, you're going to call it number 1 for layer 1. If you think it's the middle one, you call it number 2. If you think it's the least dense, you call it layer number 3. We good with that?
Yes, sir.
Then you do colors. And he basically told you what the colors were. In the video, he said purple, purple, brown, or yellow. Ooh-wee, 10 free points here, guys. Which one do you think it is?
Say the question one more time.
Would it be pink, yellow, pink?
Yes.
He told you in the video, he said that this layer was purple, this layer was purple, purple, pink. Same basic difference. If
So
you hit it,
purple, yellow, purple, or pink, yellow, purple,
and he said this layer was yellowish brown.
yellow, yellowish brown.
Okay. Now you have some post-lab questions. Okay. The sample of 175 milliliters of liquid orange juice has a density of 1.20 grams per milliliter. Okay.
Okay, so as long as we're provided 2 of the 3 necessary to figure out the other, like volume, density, mass, then we could always figure out the missing variable.
This is a tricky question, Hunter.
The sample.
Okay.
Okay.
You have the volume and you have the density of the liquid orange juice. Again, they throw a third number in there. He's asking you to calculate the mass of the liquid orange juice. Remember, you have the volume of the liquid orange juice and you have the density of the liquid orange juice.
So ignore the frozen.
I didn't say that.
Okay, to find the mass, it's just density times the volume.
There you go. Okay, next question. Calculate the volume of the solid orange juice. What you have to understand is the mass has not changed.
Okay, so we'll just take
So,
the mass and density and divide it.
which density though, Hunter?
The original one. You said it didn't change.
But the densities do change.
Oh my lord.
Once it's frozen, then it's a solid.
The mass hasn't changed. You haven't lost any mass freezing the liquid orange juice to a solid,
Yeah,
right?
yeah.
Isn't it less density?
Why is it less density?
I'll get into that in a second, but it is less. You know it's less, Hunter, you know it's less because ice floats,
Oh yeah.
right? So you were able to use this and this to get the mass of the liquid orange juice, okay? The mass hasn't changed from liquid to frozen. So you now have the mass of the frozen because it's the same as the mass of the liquid. And you have the density. Can you figure the volume of the solid?
I know we can. We just have to plug in the right things into this equation.
Then it asks you a question. Did the sample of orange juice expand or contract? In other words, did the volume increase or decrease? Based upon your life experience, does this make sense? And there are 4 reasons there. One answer is correct. This one is asking you, based upon your results of the miscibility experiment, it's asking you to compare liquids A and liquid B, and you determine whether they are miscible or immiscible. Last question. Nope, next to last question. You're to look at B and C, and you're to determine whether B and C are miscible or immiscible. It could be just something as simple as looking at where they are in the layers. If you have 2 right next to each other, you know those 2 are not miscible. And the last one, you're going to have to make a conclusion based upon the solubility of the iodine water. All right. That is the whole report.
I have another question for you.
I'm here, Monica. I have
So in your when you're doing your module 4 for your regular chem class, not this lab but this regular chem, was there instruction on the miscibility? Because like on my regular chem, it was just density. Like I don't remember. Like the first time I saw the miscibility stuff is in this lab, and I had to go like YouTube it. And I mean,
Monica,
now I get it.
Monica, in answer to your question, yes, I did talk about it.
Okay.
And I was talking about it when I was talking about solutions, and I was going through homogeneous and heterogeneous.
Oh, okay. Because I have Musgrave. I don't have you for my regular chem, so it's like
all right,
weird.
Monica, it's real simple. You use soluble and insoluble when you're talking about a solid mixed with a liquid. Does that make sense? If it dissolves, then it's soluble. If it doesn't dissolve, it's insoluble. Okay? Now, when we're dealing with miscible and immiscible, we're talking about 2 liquids, not a solid and a liquid. We're talking about 2 liquids. Okay? And here's the easy way to remember it. Does miscible sound like mixable? Right? So if two liquids are miscible, they're homogeneous, they mix and make one solution. If they are immiscible, this means they are immixable. And the way you can tell is you see two layers separated. You can generally see a line between the two layers. Monica, have you ever made salad dressing, oil and vinegar?
Yes.
Have you ever seen it separate?
Yes.
Okay, you know there's a line between the oil and the vinegar. That's what, when two liquids are immiscible, you will see a line like that. Okay? Problem solved. All you got to do is ask. You good with it? Okay. Anybody else have any other questions? Now, remember, I want you to read. I don't even want you attempting this. I don't want you attempting the results. Guys, I've been through, haven't I taken you through the reports? Each time, haven't I gone through this?
Yes, sir.
I really wouldn't do this. Just please read the labs, because if you read the labs, what the subsequent results may make a little more sense to you. Okay? Don't try and shortcut it. And basically, guys, is somebody doing something? Hunter, Monica, is somebody doing something, guys?
No.
Okay. That's basically all I got, guys. Unless you have questions. Hunter, I do want to speak with you.
Of course.
If that's it, ladies and gentlemen, I'd like to go get my fish dinner.
You enjoy that.
As long as
Absolutely.
it's catfish, sir.
I scarfed down some salmon when you weren't looking.
Bye, Professor.
No, it was swordfish. You wouldn't have liked it. Bye.
I hope your fish dinner goes swimmingly.
Thank you so much.
Said that. Oh, what?
I deserve that for the puns that I've done.
That was okay.
Somebody
Have
want
a great day.
Does somebody want to wake Maverick?
Oh, that's what I was laughing about.
This is the second week in a row, isn't it?
Yeah, I'm sorry that I laughed so hard about that. Like, I didn't mean to disrupt, but I don't know. I just saw them.
Wakey, wakey. It's not time for bed. This is not what you want your final resting place to be.
I'm just looking at it. Yo.
That's a little baby.
You know, you realize, of course, this isn't an advertisement for my class.
It should be.
Thank
Your
you.
soothing
No,
voice.
you do a great
lulls
job,
you to
and it's interesting. So I don't know. I think you just.
Who's that speaking? Is that Sophia speaking?
Yeah.
Okay.
All right. See you, Professor.
Take care.
Bye, Next week.
Take care, Michael. Philip.
Yeah.
Take care, guys.
I guess Maverick's gonna have to listen to our convo in his dream.
No, I'm going to take him out of here. Faith, you okay, Faith? Or do you have something to talk about?
No, I just wanted to see if Maverick would wake up or not. Before the
Maverick's going to be gone in a second.
Okay. Have a good night.
Yeah, have a good night. Let's see, participants. Okay, more. Remove. Gone. Okay, it's just you and me. All right. You need help with significant figures.
I do. And I don't know why, but I've been rushing to like get into things where I know I need to like just stop.
Take things as they come, Hunter. Okay. Now, you have the survivor guide, right?
Yes.
You have the survivor guide. Okay. Now, there are a ton of problems. Module 3. Module 3 or module 2? That can't be 2. We'll go with 3. 4 is density. 3. There are a ton of problems in here, okay? As a matter of fact, that's all there are, okay, Hunter? And, all right, where do you think you're having the most problems with this? Hunter, I can't hear you. You're muted.
Sorry, I apologize. I just think that I never remember, you have to use the lowest amount, and just different things like that. I just get confused because like I'll look at the test tube and I'll be like, I sometimes I don't remember it's 0.2, 1 tick it denotes 0.2, or I'll get that confused for some reason. I'm looking at the next test tube and I'm still using the same rule for the last one. Okay, now you're muted. I can't hear you. Hello? I can't hear you. Hello? I still can't hear. Did you put your headphones in or something? I can't hear you now. I still can't. Do you want to call me on my phone? I still can't hear you. Still can't hear you. That's so strange. If you want, I mean, you can call me on my phone. I'll delete your number after if you don't want me having it. Okay. I put it in the chat. Could you find, or can you see the chat? Should I type it on Google, or is this an SPC resource, or is it a Google resource? Because I've been looking at YouTube videos and it's helped a lot. Like they have Khan Academy does some stuff. Okay, Google. Okay, I'll Google that. Organic, here, let me write that down. Okay, thank you. I'll message you if I have any specific questions, all right? You enjoy your swordfish. Okay, I will. After 9, and I know where your number is. I printed it out on the course syllabus. Thank you. Okay, I'll write it down too. Thank you.
Hello. 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 Hello.